Okay, we're going to add and subtract rational numbers. So a rational number was a fraction with an expression on top and an expression on bottom, right?
Yes.
We've been simplifying them. We've been factoring them. So it makes sense to add them and subtract them. So I've just a bunch of examples today. So x over x plus 4 plus 5 over x plus 4. So rational numbers are fractions with expressions on them, yes?
Mm-hmm.
What do you have to do when you are adding and subtracting fractions?
Isn't it you only have the top? Or is that?
What is very before that even?
You have to have the same denominator.
You have to have common denominators. The denominator has to be the least common multiple. Yes?
Yeah.
The same thing. Least common multiple, common denominator. So, do I have common denominators?
Yes.
Yes. So, my common denominator is x plus 4. So, my numerator is x plus 5. Now, that was probably the simplest problem I could ever give you. But they are not like that. Okay, so 2x plus 1 over x squared plus 3x plus 3x minus 8 over x times x plus 3. So
This is easy.
a least common multiple means it's the smallest multiple of the number, right? So if I had 4 and 8, what's the least common multiple?
2.
Wait,
8.
Multiple.
Multiple,
Okay.
bigger. 8. Correct?
Yeah.
What if I had 3 and 19?
What's 19 times 3?
Yeah, you would have to take 19 times 3, correct?
Mm-hmm.
Okay. But what if I had 3 and 18? It's 18.
Yeah.
Because in your head, you know that this is 3 times 6, yes?
Yeah.
So they both have a 3. So you only need to add in a what? 6? So that's what we're doing. So do we need to, we can do 18 in our head and know it's 3 and 6. We're factoring, aren't we?
Mm-hmm.
Okay. But when we have expressions, we can't factor that easily usually, right? So we probably need to make sure we do what? Factor to see what they have in common. So the right is already factored, the left is not. So I have x squared plus 3x. What does that factor to?
X times 3, x plus 3.
No,
I meant x plus 3 now.
no. I'll go with x times
Well, if you just multiply them, then you get the same answer.
X plus 3.
x plus 3.
That's what I said.
No, you were saying x plus 3 and then you started saying x minus 3. Yes, and I said no when you
You're
said that.
wrong.
You were on the right track and then you were just plugging in the minus 3. I think your brain was just going on autopilot. So do they actually have the same denominators already? Yes. So my common denominator is x and x plus 3. I want them factored to show me that you saw you were doing the work. Does that make sense? Just like your problems last week, you were factoring everything and I never made you multiply them out.
I got a question.
What?
If we just, well, I mean, if on our paper we just multiplied the x times x plus 3, would that be wrong?
Yeah, I want them factored.
Okay.
Because we want to see, because what if I could reduce something? Should I reduce it?
Yeah.
Yeah. Okay, so now I have a plus here. So I'm not, it's nice that I have a plus because it's plus the quantity, right?
Mm-hmm.
And we've done adding, subtracting of polynomials. And we know that whatever is here has to be distributed, but a positive 1 distributed, does that change anything? No. So I essentially have, I'm going to write this step, but I will never write it again. I have 2x plus 1 plus 3x minus 8. Don't I?
Mm-hmm.
Now, why won't I ever write that step again?
Because it's combined.
Because now I need to combine like terms, correct? So I have 2x. No, I totally did not link the right things. I need to start using my erasable pens again. And nobody caught me on it. So 2x. Oh, I did.
Yeah, I was gonna say.
I just crossed. Okay.
Wow.
I just was starting to write 2x. So 2x plus 3x is 5x.
Yeah.
And then minus 7. Okay, if I could factor that, I would. Can I factor that? No. And so here is my answer. I want it factored all the way, so that way if I could reduce something, I would. Got it? Okay. Let's see. So I'm going to give you 2. And I think you can do these by yourself. So 10x minus 5 over 2x plus 3 plus 8 minus 4x over 2x plus 3. And I'll write the second one over here.
Do you want us to factor it out?
If you can, like I would wait till you add them,
Okay.
because you can't add unless it's multiplied out. These are too easy. I'm gonna make it harder.
I mean, are we adding the 2 on the bottom? Are we adding those?
Hmm?
The 2 on the bottom was just 1? Look at 6x plus 3. Oh, are we just reducing?
Mm-hmm.
Okay.
Yeah, because I factored out the 3 to see if I could reduce. Like, if I factored out the 3 and got 2x plus 3, could I reduce them?
Yeah.
Yes. Now, the other thing you might want to do is put parentheses around this so you remember that it's one thing again. So if you can't reduce the whole thing out, then you can't reduce it.
Oh, wait, that's the answer.
Mm-hmm.
I thought we were supposed to do those on what?
Mm-mm.
Okay.
No, that's the answer.
I'm stuck on the second. Yeah, same.
What should I do first?
Well, you should take out an x from the second denominator.
So my second denominator, I should factor and have x and x plus 5, right?
Yes.
So what is my common denominator going to be? No.
X plus 5?
X plus 5. And I'm going to show you why. Because up here, when we had 3 and 18, wasn't my common denominator 18? Yes. Because 3 was in common, the 6 wasn't. Okay? So we want multiples, so bigger. So if my common denominator is x times x plus 5, what is this fraction on the left missing? What is this fraction missing?
X.
An x. So I have to multiply the numerator and the denominator by what?
X.
X. I'm not actually going to multiply the denominator because I just wrote it right here, didn't I?
Yes.
So did you get x squared minus 2x minus 21?
I got minus 26.
How'd you get 26?
Oh. I accidentally added the 5.
Okay, because the 5 and the 3 can combine.
Yeah, I forgot
Now,
to add the X.
factors of 21 that have a difference of 2? No, because 21 is 3 and 7, so the difference would be 4, right?
Mm-hmm.
So we can't factor it, so are we done?
Mm-hmm.
Yes.
Is our last example, or we got some hard one?
Well, the title was what and what?
Addition and subtraction.
Okay, a question for you. Least common multiple. What is the least common multiple of 3 and, not 3, I shouldn't use 3. 6 and, I don't know, these are hard to do. I'm trying to make them hard, but they're not really hard. 24.
The least common multiple?
Mm-hmm.
So the smallest. 2.
Multiple. The smallest multiple. What multiples of 6? 6, 12, 18, 24.
So
Multiples of 24 are 24,
So 24.
48. Yeah, that's what I'm getting at. Like, this is 6, 12, 18, 24, 30, 36. Yes?
Mm-hmm.
And this is 48, 272, 120. These multiples go big, yes? So the least common is 24. So it wants to know the least common multiple of x plus 2 squared and x squared plus 5x plus 6.
Dude, golly. I'm confused.
So remember we did factors, right? We could have easily right here with 6 and 24. I like these things. I have 6 and I have 24. What do they have in common? 6. Yes? And so 6 times 1 and 6 times 4. So your least common multiple is 24. So what if I did 12 and
48.
48? No, 42.
2.
42. Okay. So what's in both 48 or 42 and 12?
3.
6.
6. If 2 and 3 both go into it, what also goes into it? 6. Don't I want the biggest one I can think of? Yeah. So 6 goes here.
Least common multiple.
No, I know, but we're trying to get the least common multiple, but we have to get back down to factors. So 6 times what is 12?
2.
2. 6 times what is 42?
7.
7. So their least common multiple is 12 times 7, which would be 84.
Okay.
Okay? Isn't that a lot easier than listing out your multiples? Yeah. So I had to do factors, didn't I? So what do I have to do to these? Factor them. The one on the left's already factored. It is already x plus 2 and x plus 2, yes? Isn't that what the x plus 2 squared means? Okay. So what's this one?
X plus 3, x plus 2.
X plus 3 and x plus 2. So I can still do, you're not going to write it out, but I can still in my head do this thing with crappy circles. What do they have in common? X plus 2. Yes?
Yes.
What do I need to finish this one? An x plus 2. And what do I need to finish this one? An x plus 3. So my common denominator is this times this times this. So my least common multiple is x plus 2 squared times x plus 3.
Yeah.
Does that make sense? Yes? Now, to really get it, I'd have to multiply it all out.
This is good enough.
And I think I'm...
So is this on one of our problems?
Well, this is how you get common denominators. So yes, it's on every problem. Okay, so we're going to start adding things without common denominators. So I have to find them, right?
We can't see what it
Okay. I'm just writing adding without common denominators in a really weird level. Okay, so x plus 3 and x squared minus 1 plus 2 x squared minus 3x plus 2. So the first thing I need to do is what? Factor the denominators. So what's the left factor to? X minus 1, x plus 1. Difference of squares, right? What's the right factor to?
X plus 2, x minus 2, x plus 2.
X minus 2,
X minus 1.
x minus 1. Okay, so what do they have in common?
X minus 1.
X minus 1. So I'm going to put that in the middle so you can see your Venn diagram on the paper. Okay? So if I have x minus 1, what's this one? Wait, we're going to have x minus 1, so this one needs x minus x plus 1. And this one needs, to finish it out, needs what? X minus 2. See how I did that? Does that help? See the Venn diagram in there?
Yes.
Okay, so now I need to multiply by what they're missing. Yes? So on the left, what is this missing of the common denominator? X minus 2. So I have to take this quantity and multiply it times what? X minus 2. And I have to take this and multiply it by
Minus 1? X plus 1.
x plus 1. So if you look down here, and if you use that common term in the middle, you multiply by the one on the other side. Do you see that?
Yeah.
You're setting it up to know what to do. So I have to FOIL both of these things, don't I?
Yeah.
Yeah.
X squared minus
So I think red and purple give me some sort of green, right? So x squared, I'd have plus 3x and minus 2x, so that would be plus x. Minus 6. Then plus 2. This plus goes with that 2. If that was a minus, it would go what? It'd be negative 2, wouldn't it? So then I get plus 2x plus 2. Now what?
we add common.
Combine like terms, right?
Yeah.
So I get x squared plus 3x minus 4.
Yep. Can't you factor that?
I'm going to just put like this because I don't want to rewrite it all. Because Emma said, can't I do what? Factor. If I can factor, should I factor?
Yeah.
Yes. So factors of 4 that have a difference. So it'd be x plus 4 and x minus 1 over x plus 1. Now I got to write them all, don't I? X minus 1 and x minus 2. So now what?
That's it.
You can't factor them out. You can reduce them out. And my final answer would be x plus 4 over x plus 1, x minus 2. And if you would like to leave that numerator in a parenthesis, then do it. So you don't try to reduce it when you can't. So it's like when you learn to factor, and then I'm like, factor completely. And then you'd factor, and like, oh, I can do it again. No, I can do it again.
Okay.
So you have to go all the way till you're completely reduced, which we've been doing. Once we add them, is it what we've just been doing?
Yeah.
Yes. So hopefully we have a subtraction one. We don't, but I think we're going to just jump to subtraction. Because really, subtraction, addition, any different?
No.
No. Okay. Do you guys notice how I factored out the purple and I got back to red? Nobody's getting my color coding. Make me sad.
Well, yeah, because the green, red and blue do not make green.
They make purple.
Not green.
Green and purple are on the opposite ends of the color.
I know, but I can't use yellow
Why?
because you couldn't see it.
Use purple. You have a
I
purple.
have purple, yes, but I need different colors.
What's purple? What is different?
No, my primaries are red, blue, and yellow. I can't use yellow.
Oh. Oh, you're doing the primary?
I was trying to because they mix and then I could take them out,
Okay, that makes sense.
That was what I was going for.
That makes sense.
but I can't.
I, thought you were
I could
doing-
get a brown. I'd mix them together and they'd brown.
No.
Yeah. Okay, anyway. So x plus 1, is it going to confuse you right next to this?
No.
No.
Okay, here. X plus 1 over x squared minus 6x minus 16
Whoa.
minus
Another one? Oh.
x minus, plus 1 over x squared plus 6x plus 8. So the first thing I need to do is what?
Factor.
Factor.
Wait, can't we just flip them? Can't we just make them the reciprocals and call it a day? That'd make it so much easier.
No. Factor. So factors is 16, then I have a difference of 6.
8 and 2.
8 and 2. So negative 8, positive 2. And the only reason I can jump from here to here is what is my leading coefficient?
1?
1. If it wasn't 1, would I have to go through the whole process?
Yes.
Okay. Factors of 8 that add to 6.
4 and 2.
Okay, so what do they have in common?
Plus 2. X plus 2. Plus 2.
Can we?
Yeah, that's so unenthusiastic.
Plus 2.
Wasn't there a show that used to be like lack of enthusiasm or something like that?
Prove
Okay.
your enthusiasm?
Yeah, curve your enthusiasm. That would be.
Which was hilarious.
I've never seen it. Okay, so I wrote my x plus 2 because that's what's in common, yes?
Yes.
Okay, what do we need? What's from the left then?
X minus 8.
X minus 8
And then X plus 4.
and x plus 4.
Then on top is 2X plus 2.
So I'm going to multiply this by x plus 4.
Oh, I forgot about this. Messy.
And I'm going to multiply this on the x minus 8. Okay, don't forget about what in the middle though.
The subtraction.
The subtraction, so is that going to still be a thing?
Yeah.
Yep. So we do have x squared plus 5x plus 4
Yeah.
minus the quantity x squared minus 7x minus 8.
Wait, X squared minus 7X minus 8?
Mhm.
Yeah, yes.
Okay. So everyone good?
Mm-hmm.
So now what do I need to do?
Like
No,
terms.
no.
Subtract like terms.
Whatever you do with the like terms.
I can't do anything with like terms yet.
Why?
Factors in
No.
Quit dancing around it and just tell us.
Whatever you do with that negative.
Oh, you-
What do you do with that negative?
Distribute.
You have to distribute it.
Or just,
So,
Minus
this
it.
is how I distribute it. Watch me. Negative, positive, positive. Did I just distribute it?
Sure.
And now I can do what?
Add like terms.
Combine like terms.
12x.
Okay, so what?
Actually,
12x
the- or is it 2x
plus 12?
squared?
Yep.
Hang on, is it 2x squared? Or, oh wait, no, that just counts. Oh
And
yeah.
I was wondering you were
she's talking to herself.
Okay, I'm talking to myself.
Okay, so did you get 12x plus 12?
Yep.
Now what?
Factor.
Factor the numerator.
Oh yeah.
So you get,
And
12.
x plus 1. 12x plus 1.
Whoa.
can I just put 12x plus 1?
Yes.
Does that do me any good? Is it going to be able to reduce?
No.
No.
So let's just leave it how it is.
No, we still got to factor it. Okay, why am I factoring it? To show that I looked, right?
Yes.
Okay. So I'm going to ask you a question. What are the excluded values? What can't x be?
negative 8 to.
Nope.
Wait, 8, negative 2, negative 4,
So negative 4, negative 2,
and then 8.
and 8.
Not negative 1.
Nope.
No, you wouldn't.
I don't care about the numerator. I only care about the denominator. So the domain then would be x couldn't equal those things also, yes?
Yes.
So just be aware that sometimes they can ask for the excluded values, yes?
Yes.
Okay, I think you need to do a subtraction one on your own and then I'm done with you.
Can we start?
Yep. Well, they just take a little bit. Next time I'll throw you the sharks and then you'll be whining.
No, don't throw us to the shark.
I will be whining.
Okay, so don't ask to be thrown there. Ooh, you ready?
Look, I got a new
Not that you say that.
1 over 3x
What?
plus 1 over 6x minus 1 over x squared.
Miss me. Come on now.
Are you serious right now?
Mm-hmm.
How are we supposed to do?
Well, you don't need to factor them because they're all factored, yes?
1, 1, 1.
Yes. I mean, there's nothing to factor.
But the bottom.
But what do they have in common?
X.
An x. They all have an x in common, yes?
Whoa.
Don't they all have an x?
Yes.
Okay. Now, I'm going to write them just in different, like, x is they in common. So what else does the first one have?
A 3.
3.
A 3.
That can go to this.
But does a 3 have in everything? No. Okay. What else does this one have?
A 6.
A 6. I don't care if 3 and 6 go together because they all have to have it, yes?
Yes.
Okay. What else does this one have?
X.
An x.
Minus 1.
Because we had 2 x's. So if I distribute this red x, do I get 3x? Do I get 6x?
Yeah.
And do I get x squared?
Yeah.
So I have to multiply by what it doesn't have. Yes? So this one has an x and a 3. So what doesn't it have?
A 6.
A 6x.
And an
So I can multiply this by 6x. See?
Yes.
Okay, so 6x.
It doesn't have a 3x.
It doesn't have a 3x. So I have to multiply by a 3x. And what about x squared?
3 times
3 times 6, which is
18.
18. My bad.
so we're going to have 6x plus 3x minus. How did it turn into a minus? Did it turn into a minus really? No. It was already there. I am going to multiply this one out. I am going to put 18x squared because I can't handle it.
What?
What?
I can't handle x, 3, 6, x.
Wait, we
That's,
can do that?
well, because it's not quantities. It's all multiplication. Okay, so what do I get? Now what do I do?
9x minus 18.
So 9x minus 18.
Over 18x squared. Word.
Am I done?
No, because we need that in the line.
I can factor out a 9. So I get x 9 times x minus 2.
Yep.
Am I done yet?
No.
Why?
Yes, you are.
I'm not. Emma's right. Why, Emma?
Why, Emma? Why?
What?
Because it still has an x squared.
Well, no. It could have an x
Can't
squared.
you factor that?
Can't 9 go into 18? Because 18x squared isn't a quantity. Like, it's just a multiplication, right? So this would be a 1 and this would be a 2. So I have x minus 2 over
2x
X
squared?
squared.
2x squared.
Yeah.
Can you factor 2 out?
No, I cannot factor.
Ah, we are
Can
not
you
going
factor a
Dang
2
it.
out of this? Can you factor a 2 out of that?
No.
Nope. So if you can't factor it, can you reduce it? No. Okay, I'm done with you.